Good day, my wonderful viewers. You're welcome once again to Frequency Online Maths. Today, we are going to prove that root 3 is what? Irrational. You know, in our previous video, we proved that root 2 is what? Irrational. We are going to use the same method to prove that root 3 is what? Irrational. So, first of all, you know, we are going to use by assumption, by assumption, let's assume that root 3 is rational. So our first assumption is that root 3 is what? Rational. So if root 3 is rational, therefore root 3 is equals to A over B, where B is not equals to what? 0. So if it is what? Rational. Now, second assumption, we are going to assume that A all over B are irreducible, or rather coprime numbers. Coprime numbers. So what does this irreducible mean? It means that they are on their lowest form, you understand? Or lowest what? Term. So coprime numbers means that um, they have only one as their what? GCF, greatest common factor. For example, coprime numbers 2 and 3, 5 and 6. 2 and 3 have 1, 2, 1, 3 as their factor. So their GCF is what? 1. So they are coprime numbers. 5 have 1, 5. And 6 have 1, 2, 3. Yes. But they have what? 1 as their what? Greatest common factor. So they are coprime numbers. There are many coprime numbers though. So are irreducible. So from this equation, root 3 is equals to A all over V. You understand? So what are we going to do? We are going to square both sides to eliminate the square root. So this we cancel this. 3 is equals to, using which rule? Power rule in indices. This square will touch everything here, B square. So we are going to multiply, cross multiply. So it's going to be 3b squared is equals to A squared. So what does this mean? It means that 3 is a factor of what? A squared. And A squared is a multiple of 3. So let me explain this here. So for example, I have that A squared is equals to 9. You understand? So I'm having 3b squared is equals to what? So is equals to what? 9. So this implies that 3 times that b squared is what? 3. 3 times 3 will give us what? 9. So now it shows that b squared is equals to what? 9. Therefore, it shows that 3 is a factor of what? 9. And 9 is a multiple of what? 3. So if, let me bring the camera down. If A squared is a multiple of what? 3. A squared is a multiple of what? 3. You know that 9 is a multiple of 3 because 9 multiples of 3 are 3, 6, 9, 12, and so on and what? So forth. So A squared is a multiple of 3. If A squared is a multiple of 3, this implies that A is also a multiple of 3. Now let me prove it here. If A squared is a multiple of 3, A squared is equals to 9, right? Now squaring both sides, this will cancel. Squaring both sides, A is equals to, we know it is going to be plus or minus, but we are not considering the minus for now. So A is equals to what? 3. Understand? So if A squared is equals to, if A squared is a multiple of what? 3. A squared is equals to 9. So A is equals to what? 3. So it means that A It means that 3 is a factor of A. If A, if this A now, this A is a multiple of 3. Have you seen it now? A is a multiple of what? 3. From here, we got A squared is equals to 9. And we say that A squared is a multiple of what? 3. And we assume that A squared is equals to 9. You can pick any other value from there. We assume that A squared is equals to 9. Now, A squared is a multiple of 3. It means that A is also a multiple of what? 3. So A is also a multiple of what? 3. As you can see, it's A is equals to 3. So 3 is a factor of what? A. And it's true. 3 is a factor of A. A is equals to 3. 3 is a factor of what? A. It's just from the number we picked. What is a factor of a number? That number that divides that number exactly without what? Remainder. 3 can divide this exactly without what? Remainder. So 3 is a factor of what? A. So that's this illustration. So therefore, we can now say that A is equals to 3 times a certain integer value, k. So substituting it in this equation, we can call this equation 1. Substituting it here, we are going to have 3b squared is equals to A is now k, 3k. So 3k squared. So we are going to have 3b squared is equals to 9k squared. Divide by 3, divide by 3. Our b squared is equals to 3k squared. So what is this thing trying to tell you again? That 3 is a factor of what? B squared. 3 is a factor of b squared. From what we did here, you see that they are depicting the same thing. 3 is a factor of b squared. Therefore, b squared is a multiple of what? 3. Now, if 3 is a factor of b squared and b squared is a multiple of 3, it also means that b is also a multiple of 3. If b squared is a multiple of 3, b is also a multiple of 3 from what we proved, you get. So and this also means that 3 is also a factor of b. You see it now. So 3 is a factor of b. 3 is a factor of what? A. So from what we said, do you see that they are what? Contradicting. 3 is also a factor of what? B. So 3 is a factor of what? A. So do you see that you say that they are what? Coprime. So 3, 1. Okay, let's assume that they say that 3 is a factor of what? A. So let's assume that we have two threes. 3, 3. What are the factors of 3? 1 and what? 3. 1 and what? 3. Do you see that they are irreducible? You understand? So example, if you have 3 over 3, 3 divided by here, 3 divided by here, you are going to get what? 1. They are irreducible. You get? So, but in this point, their GCF is what? 3. So it does not satisfy this. By contradiction, it does not satisfy it. The greatest common factor is 3, other instead of what? 1. You get? So it does not satisfy it. Therefore, we can proudly conclude that root 3 is irrational. Because according to what we stated, it didn't satisfy it. It was going contrary to what we said ab initio. Thank you for watching and God bless you. Bye bye.